Number 6, a planet is discovered to orbit around a star in the galaxy Andromeda with the same orbital diameter as the Earth around the Sun. If the star has 4 times the mass of our Sun, what will be the period of the revolution of that new planet be compared to Earth's orbital period? So I kind of like to go in reverse and work from the back of this problem because we're looking for period. And we know that velocity equals 2 pi r over t. And if we want to solve for period, we can come up with period equals 2 pi r over v. Okay? And we know the velocity when we're in orbit is going to be equal to the square root of little g times r. And since they state it's the same orbital diameter, this r is not going to change. So the velocity is dependent upon the square root of g, little g. They also tell us, though, that the mass of the star is equal to 4 times the mass of our Sun. A whole lot bigger. So the g of the star is going to be equal to g times 4 times the mass of the Sun over r squared, same orbital diameter, right? So the g of the star is going to be equal 4 times the little g of Earth. Reason being, big G is not changing, the orbital diameter is not changing, and the mass has gone up by a factor of 4. So the only factor that's changing here is this 4. All right, so we have G of the star is 4G of the Earth. We can now plug this in over here to get the velocity. Velocity is the square root of 4, or the velocity is going to be equal to 2. We could then use this velocity and plug it in up here, and we're going to get the period equals to 2 pi r over 2. Well, once again, the only factor that's changing are the 2 pi and the orbital diameter are not changing. So we're left with the period equals 1/2. So 1/2 as much is the answer.